So what are some of the advantages of interpretation? Interpreted languages typically have greater flexibility and better error diagnostics than compiled languages because the source code is being executed directly within the interpreter, giving the interpreter full access to the program's source code. This is why the debuggers in fancy development environments like Microsoft's Visual Studio, Apple's Xcode, and IBM's Eclipse interpret the code. An interpreter can cope with languages in which fundamental characteristics of the program, such as the sizes and types of variables, or even which names refer to which variables, can depend on the input data. In fact, some language features are almost impossible to implement without interpretation. In Lisp and Prolog, for example, a program can write new pieces of itself and execute them on the fly. Interpretation is very handy during development because it allows a newly modified program to be executed without waiting for potentially time-consuming compilation and linking steps. Interpretation may be desirable on small machines because it takes less space, both in terms of memory when running and on disk because no executables are generated. Executable files can be very large depending on how many libraries must be linked in by the compiler. Finally, it is much easier to port an interpreter to a new platform than a compiler because the interpreter doesn't have to generate machine code. Compilation has its own advantages. Compiled code usually runs significantly faster than interpreted code, so programmers interested in performance tend to demand compilers. In general, a decision made at compile time is a decision that does not need to be made at runtime. For example, if the compiler can guarantee that a variable is always located at a specific spot in memory, it can generate machine language instructions that access this location whenever the source program refers to that variable. By contrast, an interpreter may need to find the variable in a table every time it is accessed in order to find its location. Since the final version of a program is compiled only once, but generally executed many times, the savings can be substantial, particularly if the interpreter is doing unnecessary work in every iteration of a loop. Compilation also catches some errors earlier, when they are easier to fix, rather than waiting to detect them when the program is actually running. Although we talk about compiled languages and interpreted languages as if they are completely distinct, a dirty little secret of the programming language world is that most language implementations include both compilation and interpretation. One example is formatted output in C and Fortran, which is generated at runtime. Both C and Fortran provide format statements that control things like the alignment of output in columns and the number of significant digits for floating point numbers. Programs can define these formats on the fly during program execution because the output library routines include a format interpreter that processes format statements during runtime. Another common case is compilation followed by interpretation, which is how Java works. The Java compiler translates the original source code into machine-independent bytecode, which is then interpreted by a virtual machine at runtime. So where do we draw the line between compiled and interpreted? We generally say that a language is interpreted when the initial translator is simple. If the translator is complicated, we say that the language is compiled. The distinction can be confusing because simple and complicated are subjective terms, and because it is possible for a compiler to produce code that is then executed by a complicated virtual machine, which is what happens in Java. We still say that a language is compiled if the translator analyzes it thoroughly, rather than affecting some mechanical transformation, and if the intermediate program does not bear a strong resemblance to the source. These two characteristics, thorough analysis and non-trivial transformation, are the hallmarks of compilation.